type of joineries. I will take the models to do the experimentation on the two tests, which is the water on the surface test and the water spray test. And then I will be analysis on the water movement behavior on the three type of joints. So the source of water leakage in the precast concrete panel can be kind of categorized in many source, which is like from joinery, from the design itself, from the rainwater, the crack, or a lot of problems related to it. But mainly there are two sources of water, which is the water penetration, which is rainwater, and the water condensation. For mechanism of water leakage, the first thing is that there need to be a water on the wall. Secondly, there will be, if there's an opening, a hole through for the water to pass through, and then if there are force acting on the water, it would go through to the interior side of the wall. So the five main force for this water leakage problem is the kinetic energy, which are the rainfall and capillary actions, gravity, airflow, and wind pressure. The literature review on the solution for water leakage, this is categorized in terms of the rain control strategy. For the wall system, there are two sides, which is the wall joint and the wall element. By looking at the wall joineries, it's called like an imperfect barrier because it's not one layer of materials. So there are two main types, which is the mass joint, which can be like a grouted, non-shrink grouted joinery, and the screen joint, which can be, it's open and then nothing is filled inside. And the subcategory for that is the undrained and the drain joints. For the type of joinery that are selected for this research is this three types. The first one is the one-stage wet joint, which is grouted with a non-shrink grout. It's called a mass type joinery because one solid layers that connect the walls together. And then the second one is the two-stage joint, which is using foam backer rod with the sealant to, and then there's on the two sides with the air gap in the middle. And the third type of joint is the drain joint, which is a screen joint system, which allow the water to go in and out in the following path. So for the experimentation, this is a replicate of the ASTM E2128 standard guide for evaluating water leakage of building walls, which is known for American Society for Testing and Materials. So the test the selected type of joint will be one-stage wet joint, two-stage dry joint, and drain dry joint. And it will be experimented on two type of tests, which for each of the models. The test factor are casted in this setup. The test setup are tested on the 1 by 1 meter concrete panels, and then seal using the technique shown below before. And the test equipment there are two test equipment for the water on the surface test. The pipe is punched with hole, and then it's put on the models, and then let the film of water to run on the surface to test on the joint in the middle. And the second test is the water spray test, which I make a rack or a metal rack, and then put a spray nozzle to spray on the joinery area. For the equipment collection, I use the Bosch Professional GIS 1000C, which will measure the surface temperature and the relative humidity. The second equipment is the Seek Thermal Compact, which will capture the thermal image of the panels. The test result, I will be looking at the lower on the surface temperature to show the water leakage through the precast concrete panels, and also the color spectrum that change. If there are water leakage, the color gonna show the lower range, which is the blue range, and also the visual observation, which will show like a watermark or water spot on the concrete panels. So these are the table that show the three different type of joint on the many mechanism, or like the water prevention mechanism that it's prevented. The collected data from the experiment are put into the table here. But for easier reading, the the diagrams. So for the one state wet joint on the two tests, both of them show an increase in temperature, which shown that there is no that the increase in temperature shows that there is no water leakage. Okay, the increase in temperature is actually from the temperature of the relative temperature from the outside. In the two-state dry joint on the two tests, both of them in the overall trend, they show an decrease in the surface temperature. And the thermal image here show, although there are some water dripping from the side, but it doesn't affect the joinery area. For the drain dry joint, also show a decrease in surface temperature of the precast concrete, but there is no sign of water leakage in this one either. So for the conclusion in water movement behavior, the one state joint prevent the water as like a barrier wall, as one solid wall. But there are disadvantage for this type of joint is that if there are crack line or anything on the joinery, the water may go in as with the capillary force. For the two-state joint, because there are two layers, although they show some of the transfer of temperature to the another side of the wall, but the water does not penetrate through. Even if the water penetrates through the first layer, the gravitational force would pull the water down, and it wouldn't go to the internal layer, which is on another side. For the drain joint, it's a more unique joint where the water there's an opening for the water to go in, opening for the water to go out. So there, with the nature of the joint, the temperature of the water can transfer to the interior very easily, but there's no sign of water leakage. Yeah, thank you.